You're surrounded by artificial intelligence, probably more than you even realize. It's working behind the scenes in your Netflix recommendations, it's what's powering the sentences from ChatGPT, and it's how Google Photos can find every single picture of your dog in a split second. These tools, they feel intelligent. So that's the big question, right? How do they actually learn? I mean, how do they go from being just a blank piece of code to something that feels like it can almost think? Well, let's dive in and find out. If you pull back the curtain on most of the modern AI we use today, you're going to find something called a neural network. And its entire job, really its one and only job, is to be an incredible pattern-seeking engine. You know, the core idea here is actually way simpler than you might think. Forget about all the complicated code for a second. Just think about how you would teach a little kid what a dog is. You wouldn't write down a long list of rules like, if it has fur and 4 legs, then it's a dog. No, you just show them pictures, lots of pictures of different dogs, and you'd let their brain figure out the pattern for itself. That, in a nutshell, is exactly how a neural network learns. Okay, so if it's kind of like a brain, what are its different parts? Let's pop the hood and take a look inside. It turns out that pretty much every neural network out there, whether it's huge or tiny, is built on 3 core components. It's a really simple flow when you think about it. Data goes in one end, it gets crunched and processed in the middle, and then an answer pops out the other side. So let's break down each of those stages. First up, the input layer. And here's the most important thing to get. Neural networks are math whizzes, but they are totally clueless when it comes to things like pictures or words in their original form. So step 1 is always translation. Everything has to get turned into numbers. An image becomes a giant list of numbers representing each pixel. A word becomes a set of coordinates. It all has to be turned into the only language the network speaks, numbers. Next, we get to the hidden layers. And this is where all the magic really happens. It's not just one big calculation. Think of it more like an assembly line, where each layer in the line gets a little bit smarter. The first layer might find some really simple things, and then the next layer uses those simple things to find something a little more complex, and so on. Let's make this real. Think about face recognition. The very first hidden layer might just be looking for basic stuff, like edges and areas of light and dark. The next layer takes those edges and starts putting them together into simple shapes, like circles and lines. Then the layer after that combines those shapes into recognizable features, like an eye, or a nose, or a mouth. And finally, a layer puts all those features together and says, hey, that's a face. See? Each layer builds on the last one. And that brings us to the end of the line, the output layer. After all that processing, the network gives us its final answer. But here's the catch. It never gives you a straight yes or no. It gives you a statistical guess. It won't say, this is a cat. It'll say, based on all the patterns I've seen before, I'm 95% confident this is a cat. It's all about probabilities. So we've got the structure down, but how does the thing actually learn? How does it go from being a totally blank slate to making these confident guesses? The answer is actually pretty simple. It learns by being wrong, a lot, thousands and thousands of times. Okay, picture this. We're trying to teach a network to read handwritten numbers. First, we showed a picture of a 7. It has no idea what it's doing, so it makes a totally random guess. Maybe it says, I think that's a 2. Nope, wrong. Then comes the important part. It measures how wrong it was. The difference between its guess, 2, and the right answer, 7, is a pretty big error. So it makes a tiny little adjustment to its internal connections and tries again. Now just imagine that loop. Guess, check, adjust, happening thousands or even millions of times. It starts getting really, really good. Okay, this next part is maybe the biggest aha moment in all of AI. It's the huge, fundamental difference that makes neural networks so incredibly powerful. And it's this. They don't work based on rules that we program into them. All right, look at the left side there. That's traditional programming. A human, a programmer, has to sit down and write every single rule by hand. But what if the dog is swimming? What if it's just a picture of its nose? The rules just fall apart. Now look at the right. The neural network approach is totally different. We just dump in 10,000 photos of dogs and let it figure out the abstract pattern of dogginess all by itself. So when we say the network is learning or adjusting, what is it actually doing? Well, it's tweaking these things called weights. Think of every single connection inside this massive network as having a tiny little volume knob. That knob's setting is its weight. It says how important that connection is. Learning is just the process of the network automatically tweaking millions of these little knobs over and over again until it finds the perfect combination to solve the problem. And this quote, this just nails it. It's a total paradigm shift in how we think about programming. We're not the ones writing the logic anymore, or more like trainers providing the data. The network becomes its own programmer, discovering the logic all by itself. It's pretty amazing. Okay, so this isn't just some weird, abstract computer science concept. This pattern-seeking engine is working behind the scenes all around you all day long. You ask Alexa to play a song? That's a neural network recognizing the patterns in your voice. Spotify builds you that perfect weekly playlist? That's a network that's learned the patterns in your musical taste. From your email spam filter to an AI that can beat the world's best Go player, it's all powered by the same fundamental principle of pattern recognition. All right, now, anytime you have technology this powerful, you're going to get a ton of hype and a lot of myths. So let's just do a quick reality check to ground ourselves. First off, this idea that they think like human brains. Well, they're inspired by our brains for sure, but the reality is our own brains are worlds more complex and efficient. Second, they don't understand things. An AI that's great at identifying cat photos has zero idea what a cat actually is. It just knows that certain patterns of pixels match the cat label. And finally, bigger isn't always better. Sometimes a massive network just ends up memorizing the training data instead of actually learning the pattern. All right, so let's boil this all down. What are the key things to walk away with? 1. Neural networks find patterns by looking at tons of examples, not by following rules we write. 2. They all have that simple 3-part structure: input, hidden layers, and output. 3. The learning part is really just adjusting all those internal weights based on mistakes. 4. This means they can discover solutions on their own. And 5. This approach is now powering pretty much all the AI you use every single day. And that kind of leaves us with one last question, something for you to think about. Consider your own job, the skills that you use every day. Which parts of what you do are really based on recognizing patterns? And what kind of patterns, what kind of examples would a machine need to learn from to be able to do what you do? It's a fascinating and maybe a little scary question to think about.